Hello everyone, welcome back to Lathe Learning. My name is Aviman Andre. I am an instructor in the mechanical department. Today, I'm going to teach you the lesson of lathe machine operations. In our session today, we are going to learn the introduction to lathe machine and lathe machine safety. Let's get started. At the end of this session, learner will be able to identify different parts of a lathe machine and take safety measurement when working on a lathe machine. What is a lathe machine? A lathe is a machine tool that rotates a workpiece about an axis of rotation to perform various operations such as facing, straight turning, plane turning, taper turning, chamfering, nailing, drilling, boring, forming, thread cutting, grooving with a tool like this one, with a tool that are applied to the workpiece to create an object with symmetry about that axis. Let us talk about machining. Machining is the removal of the unwanted material from the workpiece so as to obtain a finished product of the desired size, shape, and surface quality. Like other type of machine tools, lathe machines are factory equipment used for producing machines, instruments, tools, and all kind of spare parts. Here, there is an example of different parts which can be machined by a lathe machine. We can give an example of sleeves, pulleys, bolt, flange, shafts, and gears. Let's talk about different type of lathe machine. There is a bench lathe, a speed lathe, an engine lathe, a tool room lathe, a capstan and a toolette lathe, automatic lathe, and a special purpose lathe. Let me show you the different parts of a lathe machine. Starting from this part, this is a headstock, and this is a spindle where the chuck is fixed. And this is the compound rest, and this is the tool post where we fix tool like this. We fix it here, and this is the cross slide. This one, this is the cross slide, and this is the tail stock with this hand wheel. Then this is the bed. As you see, this is the bed, and this is the feed load, and this is the lead screw, and those are legs, and this one where the bed is located, and the part which you see moving, this is the carriage, and on the carriage the upper part is the apron, the saddle, and the bottom part is the apron. So let's talk about the headstock. The headstock, this part, houses the main spindle. There is a spindle here. The purpose of the headstock is to speed change mechanism and change gears also. The headstock is required to be robust as possible due to the cutting force involved, which can distort a light bullet housing and induce harmonic vibration that will transfer to the workpiece, reducing the quality of the finished workpiece. Let's talk about the bed. This part here. And the bed of a lathe machine forms the base of machine. The purpose of this base is to support on two legs at a convenient height. It carries the headstock. As you see, the headstock is fixed on the bed. It carries also the tailstock for supporting the workpiece. It must also absorb vibration like to arise during the machining process. Let's talk about this part. This is the tailstock. The tailstock is the counterpart of the headstock fitted at the right side. As you see, it's located at the right side of the bed. The tailstock can hold tool for drilling. If you want to drill using a drill bit, you take the drill bit, you fix it in the tailstock. It can also help you for some operation like threading, limbing, and even when you want to do the cutting tapers. Additionally, it can support the end of the workpiece using centers and can be adjusted to adapt to different workpiece length. Let's talk about this part called carriage. The carriage assembly of lathe comprises a number of components with support, move, and control the tool. If I move the carriage in this direction, the cutter is moving in Z axis. If I turn this hand wheel, the cross slide is moving and the cutting tool is moving in the X axis. The carriage assembly consists of saddle, this upper part. It comprises also the cross slide. Cross slide is this part. There is also this compound lathe. There is a top slide, this one, the top slide here, and there is also a tool post. Remember, this part is also a part of the carriage and it is called apron. Let's talk about this tool post. It's the tool holding device. This is where you fix the tool. This is where you fix the tool. That's why it is called the tool post. And it's located on the top of the compound lathe. This is the compound lathe. This is the tool post. In addition to the holding of the tool, it enables the tool to be adjusted to a convenient working position. If I unlock here, I can rotate the tool and I can set the tool to any position. Let's talk about this feed and lead screw. Remember, this is the lead screw and this is the feed load. The feed screw, this one. The feed screw is a long driver shaft that allows a series of gears to drive the carriage mechanism. These gears are located in the apron. As you see here, this is the box we are talking. These gears, here there is some gears inside. These gears are located in the apron. There are some gears located here in the apron. Are driven by either change gear. As you see, this is the change gear. The change gear transfers the motion through either the lead screw and the feed screw to the carriage or to the gears which are located in this carriage. They are either driven by change gear or an intermediate gearbox known as quick change gearbox. This is the quick change gearbox. There is something we call a split nut mechanism. This split mechanism or a half nut mechanism is used to engage or disengage the carriage. You see, when I push on this split nut, the carriage will no longer move manually, but it can move if you put the machine in motion and the screw starting to turn. This carriage will move depending on the direction of this carriage, depending on the direction of this lead screw. The purpose of this split nut, we use it when we want to cut threads. There is this part. Remember, this is the compound lathe, this one. It's used for rotating the tool at any end tool post to perform the taper turning operation. If I unlock those screws, I am opening the compound lathe and I can set this compound lathe at an angle comprised between 0 and 45 in this direction and 0 and 45 in this direction. I use those angles when I want to do a taper turning. Before you operate the lathe machine, you should check the proper working condition. Let's put our machine in motion and see if it is working properly. We can change the gears. Then if I push here, you see the machine is working, the chuck is turning. If I push on this pedal, I break the chuck. If I move the carriage, I will be sure that everything can work properly. I can even decide to change any speed here. And then I push here. As you see, the speed change. Make sure that the machine responds to all commands. The carriage saddle moves smoothly with any stick slip when driven both by hand. If you want, you can drive this one by hand, or if you want, you can drive it by power. And the chuck is firmly fixed to the spindle. We are sure the chuck is firmly fixed to the spindle. Then start and stop the motor. We can start and we can stop. It's possible we can even reverse the motion. And better, if you want to walk very quickly, we can push on this brake pedal. Here are some lathe machine formula for cutting speed, feed, and depth of cut. The following are the lathe machine formula commonly used to calculate in turning operation. Those formula will focus on the cutting speed, feed, depth of cut, machining time. To operate any machine efficiently, the machinist must learn the importance of cutting speed and feed. A lot of time can be lost if the machine are not set to the proper speed and feed for the workpiece. If you want to calculate the cutting speed, better is to start by knowing what is the cutting speed. A cutting speed for turning is the speed at which the work rotates. This is also known as surface speed. There is a formula here. The cutting speed is equal to pi times diameter times RPM over 1,000. And the cutting speed is expressed in meter per minute. Let's give an example here. Suppose that we are going to machine a steel shaft with a 25 millimeter of diameter. If it is turned at a cutting speed of 50 meter per minute, let's find the RPM of the shaft. Remember, the cutting speed is equal to pi times d times n over 1,000. So if we replace the cutting speed by 50, we can get the RPM. After resolution, you will find that the RPM is equal to 637. In practice, for example, if you find 637 and it's not available here among the range speeds of your lathe machine, better is to select the lower value. For example, after calculation, we find 637, and here there is 620. Better is to select a speed of 620. Let's talk about the feed. The feed of cutting tool in lathe work are the distance to tool advance for each revolution of the work. Remember, when I move the carriage, the cutting tool also is moving. For one rotation of this workpiece, the distance done by the cutting tool, that is what we call feed. A feed is expressed in millimeter per revolution. Increased feed reduces cutting time, but increased feed greatly, if you increase feed greatly, you can reduce the tool life. The feed depends on factors such as the size of the workpiece, such as shape, strength, and method of holding the component, the tool shape, and its setting as regards overhang, the rigidity of the machine. It depends also on the depth of cut and the power available, and so on. Rougher feed are applied for roughing, and thinner feeds for finishing cuts. We can control the feed on an engine lathe by using the change gear. If you want to set any feed, you look you select the feed you want, then you set it by changing those commands here on this quick change gearbox. If you engage the machine and you put it in motion, in automatic motion, as you see, the carriage is moving because it is working in automatic motion. As the softness of the material decreases, the cutting speed also increases. If you are working with steel, you have to reduce the feed. But as long as you are working on a soft material, you can increase the feed. Additionally, as the cutting tool material becomes stronger, For example, here I have a cutting tool which is different to this one. The two are different. This one is supposed to work on hard material because it is also hard. So for a cutting tool like this is an insert carbide cutting tool, you can increase the cutting speed. In order to eliminate this time loss, we can and should use recommended metal removal lathe that have been researched and tested by steel and cutting tool manufacturers. There is a table, for example, if you are looking to the cutting speed to be used when you are working on mild steel. If you look in our table, if you are working on the mild steel using a higher speed steel cutting tool, you can set a cutting speed of 100 rotation per minute. But if you are using this type of cutting tool, you can increase the speed to 300. Let's take another example. If you are working on a soft brass using this cutting tool, higher speed steel, the cutting speed can be 175. While if you are using this insert carbide cutting tool, the cutting speed can increase and be 500. There is also another recommended feed for various material, but here we will use only the higher speed steel. For example, if you are working on mild steel, you can set a feed located in a range of 0.005 to 0.020. Here, the feed is expressed in inch per revolution. Remember, there is laughing cut and there is also a finishing cut. Laughing cut, it's when the depth of cut is high, and finishing cut, it's when you reduce the depth of cut and increase also the speed because you want to obtain a good finishing. What is the depth of cut? The depth of cut is the perpendicular distance measured from the machined surface to the uncutted surface of the workpiece. Here there is a formula. The depth of cut is equal to the diameter of the workpiece before machining minus the diameter of the workpiece after machining, or the diameter of the machined surface divided by 2. Let's talk about lathe safety. As always, we should be aware of safety requirements and attempt to observe safety rules in order to eliminate serious injury to ourselves, not only to ourselves, even for others. Please always wear safety glass. Check if there is a short sleeve. Please no tie, no link, not trying to stop the work by hand. Suppose that the machine is rotating and you switch it off. While it is not stopped, you are not allowed to stop the machine by your hand. Stop the machine before trying to check the work. After machining, you want to measure something using a vernier caliper. Don't take measurement while the machine is working. Don't know how, don't learn it. It's very clear. If you don't know how to use this lathe, don't learn it. Don't use lugs when machine is working. Lugs are cloths we use, other cloths we use to clean the machine. We are not allowed to use lugs. Suppose that you are fixing the machine or you are fixing the workpiece. After fixing the workpiece in the chuck, using this chuck key, please remove this chuck key. Remove it immediately after to use it. Do not turn the lathe if the chuck is still in the chuck key. Turn the chuck or face plate through by hand unless there is a binding clearance. Actually not allowed to turn by hand unless if there is a clearance issue. It's important that the chuck or face plate is securely tightened into the lathe spindle. We are sure our chuck is tightened. It's securely tightened on the lathe spindle. Move the tool bit to a safe distance. For example, if you finish to cut material, be sure that the tool bit is located at a safe distance. Press the tool post holder to the left of the compound rest. This will ensure that the compound rest will not run into the spin of the chuck attachment. Always the tool is supposed to be fixed on the left side of this tool post. When storing and removing chuck, face plate and centers, always be sure all mating surface and are clean and free from burns. Please, if you are, for example, removing this center inside the tailstock, make sure that the mating surface are clean. This is an example. Make sure that the tool bit, before you use the tool bit, make sure that are sharpened, are sharp and has a correct clearance angle. You check all angles if they are set. Clamp the tool bit as short as possible. For example, if you are clamping the tool, take an example of this tool. You are not allowed to clamp this tool like this. Please avoid to clamp a tool like this one. Please make sure that there is a short distance from the tool, the cutting tool edge with the tool post. Even applying and maintaining cutting fluid, this will prevent more morphing. So make sure that your machine has coolant and the coolant pump is working properly. Do not run a thread spindle in reverse. If your spindle has thread, please do not turn it in reverse direction. Never run the machine faster than the recommended speed for the specific material. After checking on the table, if you are supposed to cut this material at a cutting speed equal to 100, do not exceed and go through 200. If you are cleaning a machine, we are not allowed to use compressed air. Use care when cleaning the lathe. The cutting tools are sharp. Avoid touching those cutting tool edge because they are very sharp. Make sure the machine is turning off and clean before leaving the workspace. So after you finish your job, please make sure that your machine is clean. If it is not clean, please clean your machine before you leave the workspace. Always remove the chuck wrench after use. Avoid horseplay. When you are walking around the machine, please don't run around the machine. Keep floor area clean. Use care when cleaning the lathe. The cutting tool, remember, they are very sharp. Thank you for watching for this first session of our lesson. See you next time. Our next session will be sharpening a single point cutting tool like this. Thank you.